Okay, today let's go ahead and get into section 5.3. All right, so 5.3, we're going to continue using proportions to solve. All right, so remember we're setting up two fractions and cross multiplying to solve it. Now, let's go ahead and look at the first thing, indirect measurement. All right, so a method of proportions to measure an object. So we're going to read a word problem and we're going to set up proportions, two fractions, and cross multiply to solve it and find a missing piece of it. All right, so when we set up our fractions, it's just important that we stay with a consistent pattern and we keep things that are labeled the same in the correct spot. So you'll notice the first sentence says a blueprint for Letitia's bedroom uses a scale of 1 inches to 4 feet. All right, so this is the first thing they give us, 1 inch to 4 feet. The 1 is going to go on top, our numerator. The 4 is going to go on the bottom, our denominator. So we're going to write this as a fraction. All right, now, when we write it, we want to make sure that we're consistent with labels so that we match up our second fraction correctly. So let's look. Our first one said 1 inch to 4 feet. So that's our first fraction. You'll notice I put the inches and the feet with it so that I know. You'll notice the second part of this question says her bedroom has a blueprint of 3 inches. So because this is inches, I want that to be on top of my second fraction. And I don't know how long it actually is in feet, so I'm going to call it x feet. Now we set up both fractions, so we're going to cross multiply. 1 times x is 1x. 4 times 3 tells us 12. If I divide by 1, it tells me that x equals 12. So the actual room was 12 feet, because technically that was our label with it. You could write it as 12 feet with the abbreviation 2. That would also be correct. So again, just like we've been doing through the whole chapter, we need to make sure that we go ahead and stay with a pattern. All right, let's look at another example. Let's go ahead and read the first sentence. It measures a distance of 11, on a map, it's 11.5 inches from Madison to Wausau. The scale of the map that they tell us is 1 inch for 13 miles. So we have 1 inch for every 13 miles. Now, they told us that we went 11.5 inches, so I want the 11.5 to be on top because we had inches on top, and I'm going to put x for the miles to figure out on the bottom. All right, let's go ahead and cross multiply. 1 times x is 1x equals 13 times 11.5 will give us 149.5. If I divide by 1, it tells me that my answer for this question was 149.5. Now, notice the x was next to the miles, so technically it's 149.5 miles. All right, let's do a couple more of those. Again, stay with the pattern. On a map, the scale is approximately 2 equals 55. So let's put 2 cms on top. Let's put 55 miles on the bottom. And now let's see what next bit of info they give us. In the next sentence, they give us 6 centimeters only. So when I go to label my picture, I need to have 6 on top because centimeters are on top. And I'm going to put x miles on the bottom. All right, now again, we're staying with the pattern. The two numbers are in one sentence, and then we match up the one that they give us. If I cross multiply this, I get 2x equals 55 times 6 is 330. Solve it, divide by 2, and we get x to equal 115. Now remember, 115 would have been with the miles, so we're saying 115 miles. I'm sorry, not 115, 165. What am I saying? There we go. All right, let's go ahead and stay with our pattern then. Example number 4. This time they say that our scale is 2 centimeters for 55 miles. So let's go 2 cms on top, 55 miles on bottom. They tell us in the next sentence 2.5 centimeters. So let's put our 2.5 on top. And again, we're going to put x on the bottom for this one because we don't know how many miles are involved. Now, let's go ahead and stay with our cross multiplication. If I cross multiply this, 2 times x will give us 2x. 55 times 2.5 will give us 137.5. Solve it, divide both by 2, and I get x to equal 68.75. Now remember, that's next to the miles, so we're technically 68.75 miles. All right, here we go. Now what we're going to do is we're going to compare perimeters along with solving for a missing perimeter. So here's what's going to happen. We're going to match up a side from one of the triangles with the other triangle, and then we're going to match up a perimeter with one of the triangles with the other triangle. All right, so our ratio is now going to be a side over a side equals a perimeter over a perimeter. So let's go ahead and look. It says find the perimeter of the following. Now what I want to do is I want to match up 2 sides from both triangles in a fraction, and then I want to match up the perimeters from both. So for example, if I match up my sides, I know that 13 goes with 9.1. Now, we know the perimeter of our first triangle. Our perimeter is 36. We don't know the perimeter of the second triangle, so I'm going to call it x. We've set it up with a pattern, side over side equals perimeter over perimeter in the same pattern, and now we're ready to solve. 13x equals 9.1 times 36, which will give us 327.6. Go back and divide both sides by 13 now, and it's going to tell us that x equals 25.2. So technically our perimeter of our second figure is 25.2 centimeters if we go with the label from the first triangle. So again, a side over a side equals a perimeter over a perimeter. Now let's look at one where they don't give us a picture. All right, these are similar triangles, so let's go ahead and draw triangle J, K, and L. Now let's draw our second triangle. We want to stay with the same labeling pattern, so I'm going to go R, S, T. All right, now when we do this, we have them matched up. They're similar, but remember they're not equal to each other. They're similar. So JK, let's label our picture. JK is 11. It says RS is 22. It says that RT is 23. And it says that ST is 15. Question says find the perimeter. So I want to match a side from the first triangle with a side from the second triangle, and then I want to match a perimeter over a perimeter. So if I look at this, I notice 11 JK is similar to RS. So those two go in a fraction. I went left to right. I do not know the perimeter of my triangle over here, so I'm going to call it x. I can find the perimeter of my second figure by adding the three sides together. If I add those together, it gives me a perimeter of 60 for this figure, so I'm going to use 60 on the bottom. So again, we went a side over a side equals, we didn't know the perimeter of the first figure, so we used x. We know the perimeter of the second figure, it's 60, so we set up our fractions, and now we're ready to cross multiply. 22 times x is 22x. That should be equal to 11 times 60, which is 660. Go back and solve it, divide both sides by 22, and that's going to tell us that x is equal to 30. So the perimeter of our first triangle should have been 30. All right, so again, it's a side over a side, perimeter over a perimeter. Make sure you match it up and stay with your pattern. We went left to right again. All right, let's look at one more perimeter question, and let's look at a picture that gets a little more confusing. You'll notice they tell us the perimeter of RKI, the triangle RKI is 64, so I know the perimeter of this triangle. It's 64, so I'm going to put that on the inside just so I know what the perimeter is. All right, now I'm going to match a side with a side first. Now be very careful. I'm going to start on this left triangle. It has a 12 on the side. All right, notice 12 was WI, so that should go with RI. Well, RI on this triangle was 16, so I have 12 over 16 equals. Now, I'm going to do some work to find the perimeter of my second one. Now, the perimeter of the second one, I'm not sure what it is, so I'm just going to call it X. The perimeter of my second figure was 64. All right, so we did side over side. We did unknown perimeter over 64. Now, if I go ahead and cross multiply and solve this, I get 16x equals 12 times 64 is 768. If I divide by 16, it tells me the perimeter of the second figure is 48. Now, if the perimeter of that is 48, then to find x, I can add up all the sides on this triangle and set it equal to 48 to find out what the x was. So if I take 7x minus 2 plus 5x plus 2 plus the 12, because it's the third side, that should add up to equal 48, because that's what we got for perimeter. Now, if I do that, I get 12x plus 12 equals 48. If I subtract 12 over, I get 12x equals 36. Divide by 12, and we get x equals 3. All right, so here's a case where we first found the perimeter, and then we had to go back and find what x was, because we know perimeter would have to add up to equal the whole entire perimeter. So solve for x first. The perimeter is 48. Go back and add our three sides together and set it equal to 48, and then solve for x. All right, we're going to go ahead and do some practice now.